So we're going to have a look at sketching some cubics from root form. So for a good sketch, what do we need? We need x-intercepts, y-intercepts, and we need to know whether it's increasing or decreasing. So to begin with, a is positive, so it's going to be increasing because 3 is bigger than 0. And we can quickly work out our 3 x-intercepts. So x-intercepts, when y equals 0, 0 is equal to 3x minus 2, x plus 1, x minus 5. And as you'd probably guess, we end up with 3 solutions. x1 equals 2, x2 equals negative 1, and x3 is equal to 5. And so that gives us 3 intercepts to put. Alrighty, so then all we need to know is the y-intercept. And for that, we're going to need to set x equal to 0. So we get y is equal to 3, 0 minus 2, 0 plus 1, 0 minus 5. Bunch multiplication, we get 3 times negative 2 times 1 times negative 5. We've got 2 negatives, so they're going to cancel. So we get 3 times 2, 6 times 1, 6, 6 times 5, 30. And so we get 0, 30 as our y-intercept. And that's actually all the information we need. So let's get our Sketchiner going. Alrighty, so we're going to get 0, 30. It's going to be very high up here. And then we're going to get 1 at 2, 0, 1 at 5, 0, and 1 at negative 1, 0. So those are our 3 x-intercepts. And we know it's increasing. So because it's increasing, it means that I know that it's going to be up there like that, and it's going to be down there like that. So it just becomes a bit of a dot to dot. So it's going to go up and down and up. And there we go. You know, you can play around with some of these bits and make it look a little bit nicer. But remember, it's not going to act perfectly like a quadratic. So often you will find that they are slightly slanted. And in fact, we're not 100% sure where this peak could be. It could actually be up here somewhere, a little bit higher than where I've kind of drawn it. But for a sketch, this would be enough information to go off. Let's look at a second one. Alrighty, so before I even go to find it, this tells me something. This tells me that at x equals 3, which is one of its x-intercepts, so 3, 0 is going to be a turning point. It's either going to look like this or it's going to look like this. I don't know which yet, but it's got to look like one of these two. And the other thing is that my second x-intercept is going to be negative 2, which gives us negative 2, 0. The whole point of using root form is that you don't have to do so much work to actually find it. So this one's either going to look like one of these two things, and this one has to be a cross. So it's just going to be on the increase or it's going to be on the decrease. We don't know which, but it's got to be one of those. Alrighty, so those are my x-intercepts. Let's do the y-intercept. So we get f of 0 is equal to negative 2, 0 minus 3 squared, 0 plus 2, negative 2 times negative 3 squared times 2. Alrighty, negative 3 squared is 9. 9 times negative 2 is negative 18 times 2 is negative 36. And there we go. There is the y-intercept, 0, negative 36. Alrighty, so I've got all my information that I need, and now I can just put it onto a graph. And this one is a is less than 0, negative 2 is less than 0, so it's going to be decreasing. Meaning, up here is where it's going to start, down here is where it's going to end. And I know that it goes through 0, negative 36 here. I know that it has a turning point at 3. And then it's got a cross through at negative 2, 0. So it's going to look something It's going to be a turning point somewhere around here. It's going to come around, do a turning point there, and turn around. And notice this has to be a turning point at 3, 0, because that's what it means for it to be squared. Has to be like this because it is squared. It's got to be a turning point. Alrighty, and this one over here is just -2, 0. And there is my quick sketch. Obviously, I could label the x-axis x. I could write the name of the function, do all of that stuff. But this is just a quick sketch. See you in the next one. Goodbye.